For years, most crayfish were exported to China until a sudden trade halt in 2020 left Australia with a crayfish surplus and rivers at risk of overcrowding. With river ecosystems in danger, scientists and conservationists came up with a wild plan. Move 1 million crayfish from rivers to farmlands. The idea was bold. Relocate these aquatic animals to agricultural fields, hoping to help both the rivers and the crayfish. It was a massive gamble with no guarantee of success. The plan involved capturing, transporting, and releasing a huge number of crayfish into a completely new environment. Could these river dwellers adapt to life on land? The world was about to find out. This is the story of Australia's crayfish gamble, a real-life experiment with stakes as high as the outback sky. The crayfish relocation began with an economic shock. China suddenly stopped importing Australian rock lobsters, devastating a $500 million industry. With nowhere to sell their catch, fishers faced financial ruin and rivers became overcrowded with crayfish. Overpopulation led to fierce competition for food and shelter, threatening the delicate river ecosystem. Too many crayfish meant smaller organisms were being wiped out, and disease risks soared. Scientists knew they had to act fast to prevent ecological collapse. The solution? Move the surplus crayfish to farmlands where they might find new food and shelter. The fields offered space and resources, and the hope was that crayfish could adapt to this radically different environment. This creative plan aimed to relieve river pressure and give the crayfish a second chance. It was a desperate measure, but also a groundbreaking experiment in wildlife management. Could a species thrive after such a dramatic move? The project set out to answer that question with the future of both rivers and crayfish hanging in the balance. Sometimes the wildest ideas are the ones that work. Moving 1 million crayfish was a logistical feat, one that required months of planning, coordination, and a dedicated team of experts. The operation began at dawn with conservation workers and scientists gathering at the riverside site surrounded by crates, nets, and specialized equipment. Teams of fishers and scientists carefully captured only the healthiest crayfish using special nets and pots. Each crayfish was inspected for signs of disease or injury, ensuring only the strongest individuals would make the journey. The selected crayfish were placed in climate-controlled tanks filled with cool, oxygenated river water. These tanks were equipped with advanced filtration and oxygenation systems to minimize stress and keep the crayfish healthy during transport. Drivers took special care, traveling at night or early morning to avoid the harsh sun and keep the crayfish safe. Every stop along the route was carefully planned with regular checks to monitor water quality and crayfish well-being. Upon arrival, the team released the crayfish in small groups into damp, sheltered areas of the fields, never just dumping them on dry land. Each release site was chosen for its moisture, shade, and natural cover, giving the crayfish the best chance to adapt. Every step was methodical and documented. Scientists used checklists and monitoring equipment to track each crayfish's journey, ensuring nothing was left to chance. The operation was a race against time and temperature, requiring precision, teamwork, and constant communication. Every minute counted as the team worked to beat the rising sun. Watching the crayfish move across their new terrain was like witnessing a miniature migration. Thousands of tiny armored pioneers venturing into the unknown. The real test would begin the moment the crayfish touched the soil as they started to burrow and make their new home in the wild. The journey was tough. Crayfish are incredibly sensitive to changes in water quality, temperature, and even the slightest motion. Every moment out of their familiar environment was a challenge, and the team had to monitor conditions constantly to keep them safe. Even with careful transport, stress and injury were constant threats. Some crayfish lost claws or suffered shell damage, and workers had to inspect each one for signs of trauma or illness before moving forward. Coordinating the capture, transport, and release of so many animals was a logistical marathon. Teams worked around the clock, loading crates, checking water quality, and making sure every crayfish had the best chance of survival. Once in the fields, the crayfish faced a world they'd never known: predators, dry air, and unfamiliar food sources. The landscape was harsh with little water and sparse vegetation. Birds, foxes, and snakes saw them as easy prey, and dehydration was a real danger. The sun was relentless, and the crayfish had to avoid drying out while staying hidden from predators. The crayfish had to quickly find shelter and figure out what to eat: roots, insects, or something else entirely. Every day brought new challenges as they explored their surroundings. Scientists watched closely, taking notes and discussing every behavior. They were asking the crayfish to rewrite their survival guide on the fly, adapting to a world that was nothing like their old home. The first weeks were critical. Only the most adaptable would make it. Some crayfish quickly learned to burrow or hide, while others struggled to cope with the new conditions. Would they find a way to survive, or would the experiment end in failure? Researchers monitored survival rates, hoping to see signs of adaptation and resilience. The fields became a living laboratory, testing the limits of adaptation. Every corner of the landscape offered a new test for the relocated crayfish. Every day was a fight for survival in this new world. The experiment pushed both crayfish and scientists to their limits, revealing just how tough and vulnerable these tiny creatures could be. As night fell, the crayfish continued their search for food and shelter, guided by instinct and the hope of a new beginning in the Australian wild. 1 year later, scientists returned to the fields, and what they found was astonishing. The crayfish had not only survived, but thrived, proving far more adaptable than anyone expected. Healthy crayfish were everywhere, having established a new population in the fields. Even more surprising, the crayfish had transformed the land itself. Their burrows aerated the soil and improved water retention, making the fields more fertile. Farmers noticed healthier crops and less compacted soil, a completely unexpected benefit. The crayfish also adapted their diet, eating weeds and agricultural pests like slugs and snails. This natural pest control reduced the need for chemical pesticides, helping both farmers and the environment. The biggest surprise: the crayfish began to reproduce, with scientists finding eggs and juveniles in the soil. The fields now supported a self-sustaining crayfish population. What started as a desperate experiment became a model for creative conservation. The crayfish had become ecosystem engineers, reshaping their new home. Their success opened new possibilities for managing wildlife in crisis. Sometimes nature's resilience is the greatest surprise of all. The impact of the crayfish move was felt in both rivers and fields. In the rivers, removing the surplus crayfish restored balance. Other species rebounded. Plants regrew and disease risk dropped. The ecosystem healed, showing the power of active management. Meanwhile, the fields evolved into a new kind of ecosystem. Crayfish burrows created habitats for insects, worms, and amphibians, boosting biodiversity. The fields became richer, blending agriculture with a touch of wildness. The experiment revealed how a species' role can change dramatically in a new environment. In rivers, crayfish were keystone species. In fields, they became soil engineers and pest controllers. The project was a real-world test of adaptation and ecosystem engineering.